Ignition sequence starts.
Good morning and welcome to Mission Control Houston. This is a live view inside of the International Space Station Flight Control Room, located at the Johnson Space Center. What you see now is the Orbit 2 team of flight controllers keeping a close eye on station systems as the astronauts and cosmonauts in space get close to the end of their work week. In addition to their usual workload of scientific research and station maintenance, this past week in orbit was crammed full of all sorts of important activities, both inside and outside of the space station, setting one of the Expedition 59 crew members on their very first spacewalk.
Welcome to Space to Ground. I'm Gary Jordan. This week, 2 cosmonauts ventured outside the space station for a spacewalk. Expedition 59 Commander Oleg Kononenko and Flight Engineer Alexei Ovchinin conducted the 4th spacewalk of 2019. After heading out the hatch of the Pirs docking compartment airlock, the duo set out to install handrails on the Russian segment of the complex, retrieve some science experiments, and conduct maintenance work. The 2 cosmonauts paid tribute to Alexei Leonov for his 85th birthday with placards added to their Orlan spacesuits for the excursion. Leonov was the first human to conduct a spacewalk on March 18, 1965, during the Voskhod 2 mission, when he exited the spacecraft for 12 minutes. Important science being conducted in microgravity is getting ready to come back to 1G. Station astronauts will have much of this Sunday dedicated to loading up the SpaceX Dragon with science for its return home on June 3rd. Among the more than 4,200 pounds of cargo returning to Earth includes experiments in protein crystal growth, rodent research, microalgae, and DNA studies. Tune in to live coverage of Dragon's departure from station on NASA TV or the agency's website. There's a lot of science to cram into the Dragon for return home, some of which replicates the structure and function of human organs. But when they're the size of a thumb drive, it makes it a bit easier to fit. Tissue chips are tiny devices that contain human cells in a 3D matrix that helps scientists study how those cells respond to stresses, drugs, genetic changes, and now microgravity. Chips specialize to look at areas like lung host defense, the blood-brain barrier, musculoskeletal disease, and kidney function can be tested using facilities on the International Space Station to see what happens to these organs if you take away gravity from the equation. Tissue chips will be returning on the SpaceX Dragon to Earth so scientists can continue studying these functions and see if there's an effect when switching back to 1G and whether the changes are reversed from what they've seen in microgravity. Keep sending in your questions using the hashtag AskNASA. We'll see you next week.
Like Gary mentioned, tissue chips and other experiments will make their way home this Monday, June 3rd. NASA TV coverage will begin right here that morning at 10:45 a.m. Central Time. And as always, you can also catch that activity online at nasa.gov. Preparing the hardware for voyages out into space is only part of the International Space Station's mission of preparing for NASA's future flights of exploration. Scientists are using the station to find ways to protect human explorers from the negative effects of being in weightlessness, and from the conditions they will encounter on long trips to deep space, including the galactic cosmic radiation that comes from supernovas.
One of our biggest challenges on a mission to Mars is protecting the crew from radiation. You can't see it, you can't feel it, you don't know that you're getting bombarded by radiation, but we do have operational dosimetry and crew personal dosimeters that we can measure it.
Space radiation comes from 3 major sources. One is there are radiation particles trapped around the Earth, and they're called the Van Allen radiation belts. The second source of radiation is from the sun. During times of intense solar activity, there can be solar storms and high fluxes of radiation. Protons in particular can reach Earth. The third source of radiation in space is called galactic cosmic radiation, and that's the one that's of most concern for emission to Mars. The galactic cosmic rays come from exploding stars that we call supernovas.
So I think one of the common misconceptions about space radiation is just how different it is from the type of radiation we have here on Earth. So here on Earth, when you think about sitting down in a dentist chair, they put some kind of lead blanket on your chest to protect you against X-rays. In space, it actually is very different. We don't want heavy materials because it makes the exposure worse. We want things like hydrogen, things like water and polyethylene. The primary reason for that is in space we have particle radiation instead of electromagnetic radiation. Particle radiation is basically everything on the periodic table, hydrogen all the way up through nickel and uranium, but moving at speeds that are close to the speed of light. So thinking about the differences between Earth-based radiation and space radiation, we have a long history and a decent amount of data about the biological consequences of exposure to terrestrial radiation. Where we lack data and we have a large amount of uncertainty is the biological consequences of space radiation. And so really the next steps are, and the ongoing steps are to try to understand those exposures better and the biological consequences that follow them.
Up there in orbit, the astronauts and cosmonauts can also experience structural changes to their hearts during long-duration spaceflight. But exactly what and how that change occurs is not yet clearly understood. That's why researchers are investigating cardiovascular stem cells, so they can get a better understanding of the role that those cells play in the makeup of our hearts as well as tissue regeneration.
We're one of the first labs to be sending cardiovascular progenitor cells, so we know that they're an early population of cells. They're very potent in what they can become. We're able to create different types of cardiac tissue, whether it be cardiomyocytes, the heart muscle cells, or endothelium, the lining of blood vessels. These cells that we work with have the capacity to become a variety of different cardiovascular derivatives, and they function in a unique way in response to the environment and to different treatments. And so there's a lot that we can learn from these experiments. So the Kearns-Yonker Laboratory has been studying cardiovascular progenitor cells for a while and using them for cardiac repair and developing biologically active tissues. We'll be looking at disparities in the response of cells obtained from neonatal patients versus adult patients, and how that disparity exists at a molecular level. We'll be able to compare the microgravity exposed cells to the simulated exposed cells using the same clones. We'll be able to compare these two results and see if we can use simulated microgravity or even some type of microgravity-inspired treatment to help really promote cardiac repair. We're really excited for the spaceflight. We've been learning quite a bit even from the simulations, and we think that with the spaceflight we'll be able to truly extend these observations and hopefully promote cardiac repair, develop biologically active tissue, and even advance these insights into anticipating and treating illnesses in space.
In learning more about radiation and the other aspects of a long-duration spaceflight, the International Space Station is helping us know what it will take to make those successful journeys out into the solar system one day, like to the Moon and Mars and other destinations. Here are a few examples of how the station is building those missions of the future.
So you want to go to Mars. How does NASA's International Space Station help us extend human presence into deep space? In the future, when astronauts land on Mars, it will be thanks to some important lessons that we learned on the International Space Station. Rewind. 240 miles above the Earth, the International Space Station is where we currently live and work in space. Here's what we've learned so far. First, there's taking care of our astronauts. Prolonged weightlessness can lead to muscle and bone loss, vision changes, balance, and coordination loss. Thanks to the space station, countermeasures are being developed to keep astronauts healthy for long-duration missions. Then there's the equipment. Spacecraft communication, water recycling, air, and power production are all being test-driven on the International Space Station. What we learn about operating and maintaining our gear in the harshness of space will pave the way for future missions into our solar system. And that's how the space station is helping us extend human presence into deep space. For more information, visit this NASA website.
The International Space Station has a big mission to support future exploration into deep space, serve as a science laboratory, promote international cooperation, and encourage commercialization of spaceflight and space research. All of those goals come together in one program, which uses the station as a launch pad for a series of small satellites known as Cubesats.
Small satellites yield big discoveries. Presented by Science at NASA. Remember the old adage, big things come in small packages? NASA has updated it in the form of Cubesats. Imagine a real working satellite that's so small you can hold it in your hands. Just 4 inches or 10 centimeters across, these cubes can be expanded incrementally depending on their specific mission objectives. Originally developed in 1999 by Cal Poly San Luis Obispo and Stanford University for education purposes, NASA has since used them for new science missions and to test new electronics, sensors, and software that might be included on larger missions. Mike Sieblum, Chief Technologist for NASA's Science Mission Directorate, says, "The ability to test new technology at a fraction of the cost of a larger satellite makes them invaluable. It really opens your eyes to many possibilities." Just as eye-opening is the way Cubesats are quickly unlocking new scientific data. For example, while conventional satellites have long observed clouds and have provided estimates of the liquid precipitation they hold, they have never observed the smaller ice particles that create enormous rain clouds. The Cubesat, known as IceCube, contained a new sub-millimeter wavelength radiometer that could make a space-based measurement of the small frozen crystals that make up ice clouds. After being deployed from the International Space Station in May 2017, IceCube created a global map of ice clouds around the planet. Someday, this technique may help improve long-range weather models and forecasts.
A long way from Earth, Marco A and B travel to Mars and are the only CubeSat so far to leave Earth's orbit.
When the InSight mission was launched in May of 2018, the Marco A and Marco B CubeSats also began their 7-month journey to Mars.
Now InSight has successfully landed on the Red Planet. One of Marco's roles was to help relay communications during InSight's landing process. Landing data was transmitted to the Mars Reconnaissance Orbiter, where its radio stored and forwarded results to Earth after a delay. Marco A and B acted as a bent pipe signal relay during this critical stage of the mission to allow communication from Mars to Earth to happen in almost real time.
According to Charles Norton, Special Advisor for Small Spacecraft Missions in NASA's Science Mission Directorate, another advantage of these compact cubes is they allow for very focused scientific inquiries to take place. The Miniature X-ray Solar Spectrometer CubeSat, or MINX for example, is a student project using a commercial laboratory detector in space. MINX measures the soft X-ray solar spectrum in the gap of energy coverage between 2 other missions, RESI and IRIS. This gap region in the solar spectrum is important in the excitation of the Earth's ionosphere and of particular interest for observations of solar flares and active regions. Or consider a discovery as monumental as the origin of the universe itself. One long-standing mystery for astrophysicists is where 1/3 of the baryonic or ordinary matter that existed during the early formation of the universe might be found today. Scientists suspect it lies in the very hot halos of gas that surround galaxies. HaloSat is a CubeSat that will examine X-rays from oxygen atoms surrounding our Milky Way to determine how much missing matter may lie in the halo of our galaxy. While small in size, CubeSats have potential to make big scientific and technological impacts on Earth, in our solar system, and deep into the universe. For more about other science missions, both big and small, visit science.nasa.gov.
Currently on board and carrying out all of the important tasks for the International Space Station are 6 crew members from Russia, the United States, and Canada. And even though they're 250 miles over our heads, sometimes you have the chance to see their orbiting home from your own neighborhood. Flight engineer Nick Hague shares how you can use the Spot the Station website at nasa.gov to find out when the International Space Station may be visible to you.
Did you know that we're traveling at 5 miles a second? We're going around the Earth so fast that we orbit it every 90 minutes. That means on the space station we see 16 sunrises and sunsets each day. Every one is magical to watch. But more important than the view, we depend on the sun's light to power our space station, and we use massive solar arrays to soak it up. Those arrays are so large that when the sun's light glints off them, it's possible to see us from the ground. That means you can look up in the sky at dawn or dusk and see our spaceship flying overhead. So take a few minutes to step outside, spot the station, wave hello to us, and remember what we represent. People from across the globe committed to working together to improve life for everyone on Earth.
One of the key elements that keeps the International Space Station running smoothly is solar energy. Astronauts rely on this renewable energy source to power the machines they need for their science work and for their survival. In this demonstration video, astronaut Ricky Arnold explains the process behind generating the power from the station's solar arrays that produces the electricity for astronauts as they live and work on the orbiting laboratory.
Hi, welcome aboard the International Space Station. I'm astronaut Ricky Arnold, and I'm currently at one of our human research facilities on ISS, where you can see centrifuges, laptops, and other scientific equipment. Across from me is another one of these experiment racks, where you can see ultrasound imaging, more laptops, cameras, other equipment, all stuff that requires electrical power. In fact, we have so much equipment for science and life support that our electrical system has about 8 miles or 13 kilometers of wiring to make it all work. So where does this energy come from? Let's have a look. From here in the cupola and through other windows, you can easily see the solar arrays soaking in the sunlight. They are massive. These 4 solar arrays are made of solar cells, which are purified chunks of the element silicon. Together, the solar arrays contain a total of 262,400 solar cells and cover an area of about 27,000 square feet, more than half the area of a football field. That's huge. When the station is in sunlight, the solar arrays produce about 60% more power than we actually need during the daytime. That extra power goes directly to charging our lithium-ion batteries. Now, those batteries are essential because they provide the power we need during the 16 night times we have per day here on the space station. The energy our solar arrays can produce is enough to power 40 homes, and we can maximize the power we generate by rotating the arrays in 2 axes, one like a windmill to track the sun through the course of the day, the other to track the sun's inclination, or its angle in the sky. The space station's electrical power system uses direct current to provide energy for our laptops, lights, water recovery system, and science experiments. Thanks for coming aboard today. Now back to Earth.
Christina Koch is just 2.5 months into her first spaceflight, and she's set to stay on orbit until February of 2020. Prior to coming to NASA, she accrued many of the usual credentials necessary to be selected as an astronaut, but there is a lot more to her story. We're about to take a look at her favorite extreme pastimes, which include a shocking scientific creation and several adventures that brought her to where she is today.
One thing I love is outdoor activities. I love rock climbing, surfing, camping, backpacking, anything that's a challenge that puts me in kind of a circumstance that I have to think hard to get out of or just enjoy the outdoors. So those are some of my favorite things. My favorite vacation ever is camping trips with my little sister. She's about 20 years younger than me, and we like to go out on adventures in the West, everywhere from Montana to Utah, and everywhere in between, and we just have a ball. One thing people are surprised to hear about me is that I have actually ridden a motorcycle solo across the country. The trip was from North Carolina to Montana, and I camped along the way by myself, and it was a phenomenal trip. I learned a lot about self-reliance, planning, and also just enjoyed every minute of kind of seeing the country go by. When I was in college, I was majoring in physics, and I took it upon myself to build a lightning machine, which is also known as a Tesla coil. It's a device that was invented by Nikola Tesla, and it produces actual lightning strikes that are fairly long. And I remember it was a summer project for me, and I invited a bunch of my friends over in college to check it out, and they were all completely baffled at, one, how I did it, why I chose to do it, but at the same time, I think they knew that it was near and dear to my heart. I'm kind of a geek at heart. I studied abroad in Ghana, which is in West Africa, and that trip was one of the most profound experiences of my life. It taught me the perspective that not everything that I had come to know so far in life was the same the world round, and that my experiences and my way of seeing the world was just one of many ways. And I learned about an entirely different culture and came to love it.
For nearly 2 decades, astronauts from around the globe have been traveling into space to work on groundbreaking science that pushes the boundaries in several fields. During his mission back in 2017, NASA astronaut Randy Bresnik sought to capture the beauty of the spacecraft in a powerful series of photos titled "The International Space Station as Art." The International Space Station has given us 20 years of scientific research and a platform to develop, test, and perfect a new fleet of vehicles. This next video highlights how the knowledge we continue to gain from the work on board this orbiting laboratory is vital to our future in space.
The International Space Station, a football field-sized, million-pound laboratory flying around planet Earth at 17,500 miles per hour. It's our home in low Earth orbit and the bridge to exploring the far reaches of our solar system. A place to learn what it takes to live, to work, to thrive in space. Thanks to space agencies representing more than a dozen countries around the world, it went from the drawing board to liftoff when the first piece flew into space in 1998. That kicked off over a decade of construction, hauling the station to orbit piece by piece on NASA's space shuttle and Russian rockets. And after the first crew arrived in November 2000, we started an unbroken streak of humans living and working in space. Building on the legacy of past outposts like Skylab and Mir, the International Space Station became the training ground for humanity's next great journeys. Learning how to live in space for extreme periods of time, building and perfecting the technologies necessary to travel to our neighbors in the solar system. It gave us a place right on our doorstep to prepare for the next giant leap into the unknown. And thanks to the station, a new era in outer space is unfolding. What was once the domain of only nations and governments is now populated by a growing space fleet from American industry. Private spacecraft to fly cargo and crew members, new habitats and technologies for future space missions, and an open door for companies, research institutions, and even students around the world to do research in space that have never had the opportunity before. All laying the foundation for a robust economy in space. There have been thousands of experiments, hundreds of spacewalks, endless hours of challenges and successes, all done by humans hailing from countries around the globe. The International Space Station is what we can achieve as a planet when we come together to do the things that are hard. And the work isn't slowing down, because we're ready for the next giant leap. Because we're ready to go farther. Because what we do and learn along the way is for the benefit of all of humankind.
If you'd like another look at the stories we featured today, check us out on YouTube and Facebook, right there at those addresses in that blue box on your NASA TV screen. And while you're there, feel free to take a look at all of the other cool stuff available, highlighting NASA and America's human spaceflight program. And if you need even more space in your day, you can check out Houston, We Have a Podcast. The show features folks around NASA talking about their work in all aspects of space exploration. New episodes post on Fridays, so today we bring you an interesting talk about the impacts of isolation on astronauts and on regular people, like rock stars. In today's episode, Gary Jordan talks with a psychologist and a veteran NASA astronaut, as well as the members of the band Shinedown, as they explore coping with isolation on the job. This special conversation took place earlier this month during a live Facebook and NASA TV event. Go to nasa.gov/podcast to find that episode, as well as the full library of all NASA podcasts, all of which you can also listen to on Apple Podcasts, Google Podcasts, and SoundCloud. This is Mission Control Houston.